So let us cover Unit 1 vector spaces. And the first question is determine if W is equal to 1, 3, minus 4 is in null A, where A is equal to 3, minus 5, minus 3, 6, minus 2, 0, minus 8, 4, 1. So first we have to write what is the given matrix. So what is the given matrix? A is equal to 3, minus 5, minus 3, 6, minus 2, 0, minus 8, 4, 1. And W is equal to 1, 3, minus 4. Now what is null A given by? Null A is given by AX is equal to 0. Now we will consider AW. That means we need to multiply the A matrix and the W matrix. Now how to multiply? First row multiply with first column. So 3 ones are 3. Minus 5 into 3 is minus 15. Minus 3 into minus 4 is plus 12. Now second row with first column. So change the line. 6 into 1 is 6. Minus 2 into 3 is minus 6. 0 into minus 4 is 0. Then third row, first column. Minus 8 plus 12 minus 4. So 12 plus 3 is 15. 15 minus 15 is 0. 6 minus 6 is 0. Minus 8 minus 4 is minus 12. And minus 12 plus 12 is 0. Okay. So that means AW is equal to 0. Therefore, you can say W is in null A. Take the next question. Here A matrix is given, U matrix is given, V matrix is given. We have to determine if U is in null A, and also we need to check if U can be in call A. And the second bit is determine if V is in call A and could V be in null A. Okay. So first let us write what is the given matrix. So given matrix is A is equal to 2, 4, minus 2, 1. Minus 2, minus 5, 7, 3. 3, 7, minus 8, 6. Then U equals 3, minus 2, minus 1, 0. V equals 3, minus 1, 3. Okay. So first bit is we need to find the null A. So what is the formula? What is null A given by? It is given by AX is equal to O. So here in the place of X, we will take U. So consider AU is equal to what is A matrix? 2, 4, minus 2, 1. Minus 2, minus 5, 7, 3. 3, 7, minus 8, 6. Multiply this with U matrix. U is 3 minus 2 minus 1, 0. Now let us multiply these two. First row with first column. 2 into 3 is 6. 4 into minus 2 is minus 8. Minus 2 into minus 1 is plus 2. 1 into 0 is 0. Second row, first column. Minus 6 plus 10 minus 7 plus 0. Third row, third column. 9 minus 14 plus 8 plus 0. So 6 plus 2 is 8. 8 minus 8 is 0. Minus 6 minus 7 is minus 13. Minus 13 plus 10 is minus 3. 9 plus 8 is 17. 17 minus 4 is 3. So this is not a null matrix, right? This is not equal to 0, 0, 0. Therefore, AU is not equal to 0. which means U is not a solution. U is not a solution of Ax is equal to 0. Therefore, U is not in null A. Also, you can see U contains 4 entries and call A is subspace of R power 3. Therefore, U could not be in call A also. So, U is neither in null A nor in call A. Now, moving on to the second bit. For the second bit, now what is the formula for call A? Call A is given by Ax is equal to B. That is, Ax is equal to V. Because in the question, V matrix is given. So in the place of B, we will write V. So what is the augmented matrix? The augmented matrix AV is AV is equal to 2, 4, minus 2, 1 and 3. Minus 2, we are combining both A and B matrices. Okay, 7, 3 and minus 1. 3, 7, minus 8, 6, 3. Now here we need to apply row transformations to make these two zeros. See, we need to make these two zeros by using row 1. So R2 is R2 plus R1 and R3 is 2R3 minus 3R1. Okay. Now, what will it become? First row, we are not changing. 2, 4, minus 2, 1, 3. Then, how we are changing row 2? Row 2 plus row 1. So, add row 2 and row 1. Minus 2 plus 2 becomes 0. Minus 5 plus 4 becomes minus 1. 7 minus 2 is 5. 3 plus 1 is 4. 3 minus 1 is 2. Now, how we are changing R3? Multiply third row with 3 and first row, multiply third row with 2 and first row with 3 and then subtract them. So 3 2s are 6, 6 minus 6, 0. Then 7 into 2 is 14 minus 3 into 4 is 12. 14 minus 12 is 2. And then minus 8 into 2 is minus 16 minus 2 into 3 is minus 6. So plus 6. That is minus 10. Now here third row multiply with 2. So 6 2s are 12. Minus first row multiply with 3. 1 3s are 3. So that makes 9. Then 3 into 2 is 6. Minus 3 into 3 is 9. That is minus 3. Did you understand? So this way you can do it in rough column and you can put the values. Now, after getting this matrix, we need to make the next one 0. Okay. So for that, what I will do? We are R2 is minus R2 because I want to make this 1. Okay, this element I want to make it as 1. So I am multiplying with minus. So, and also we can take, we want to make this as 0. So R3 is R3 plus 2R2. Okay, so that will give you, first row we are not changing, 2, 4, minus 2, 1, 3. And then here you have a 0, 1, minus 5, minus 4, minus 2. And here R3 plus 2R2. So this is 0, 2 plus 2 is 0, minus 10 plus 10 is 0. Then 9 plus 8 is 17. Then minus 3 plus 4 is 1. So you can see the system of equation Ax is equal to V is consistent because the last row is not becoming completely 0. So it is consistent. Therefore, you can say B is in call A. And because V contains 3 entries, and over here null A is subspace of R power 4. Therefore, V could not be in null A. Understood? Now take the next question. Let B1 is equal to 2, 1, B2 equals to minus 1, 1, X equals to 4, 5, and beta equals to B1, B2. Then we need to find the coordinate vector. So first, let us write the given basis. So this beta equals to B1, B2 is given now. This is called basis. So given basis, beta is equal to B1, comma B2. And here B1 is 2, 1. B2 is minus 1, 1. And what is the vector? Vector X equals to 4, 5. Now, how to find out beta coordinate? So whenever coordinate vector x beta is given, that means we need to find out beta coordinate. Beta coordinate C1, C2 of x is C1, B2 plus C2, B2 is equal to x. Now C1 into, now in the place of B2, substitute the B2 matrix, that is minus 1, 1 plus C2 into B1 matrix. 1 minute. This is C1 B1 plus C2 B2. So in the place of B1, let us write B1 matrix, that is 2 1, and here B2 matrix minus 1 1 equals to 4 5. That is X. Now that means we can arrange this in the matrix form. 2 minus 1 1 1 into C1 C2 is equal to 4 5. Now what is the augmented matrix? The augmented matrix is 2 minus 1 4 1 1 5. Now we need to apply row transformation to make this element 0. So how can we make that? R2 is 2R2 minus R1. So if you apply the row transformation, you will get 2 minus 1, 4. We have not changed the first row. Now in the second row, we are applying the row transformation. So 0, 3 and 6. Now in the second row, you can see both 3 and 6 are multiples of 3. So you can cancel it by 3. R2 is R2 by 3. So 2 minus 1, 4, 0, 1, 2. Now here I can make this element as 0. How? R1 is R1 plus R2. 1 minus 1 will become 0 if you add both the rows. So 2, 0 and 4 plus 2 is 6. Then 0, 1 and 2. Now again you can see 2 and 6 are multiples of 2. So we can take R1 by 2. So that is 1, 0, 3, 0, 1, 2. So you got this in the identity matrix form, right? 1, 0, 0, 1. Now, therefore, the solutions are C1 is equal to 3 and C2 is equal to 2. So this part we have to convert it into identity matrix. And the remaining two elements will be C1 and C2. Understood? So therefore, coordinate vector x relative to b, x relative to beta is we denote it by x beta, that is equal to 3, 2. Understood? Now, take the next question. This is an LAQ. Very important. If H and K are two subspaces of a vector space V, then show that H plus K is also a subspace of V. So first let us write what is given to us. Given V is a vector space. H and K are subspaces of V. And H plus K is equal to, we define this way, W such that W is equal to U plus V for some U in H and some V in K. Since H is a subspace, that means 0 belongs to H. Now K is a subspace, so 0 belongs to K. Now let us say W1 equals to U1 plus V1, where U1 belongs to H and V1 belongs to K. And W2 is equal to U2 plus V2, where U2 belongs to H and V2 belongs to K. Then if we add them, W1 plus W2 will become U1 plus V1 plus U2 plus V2. Now let us separate U and V. So U1 plus U2 plus V1 plus V2. Now since U1 belongs to H and U2 belongs to H, that means we can say U1 plus U2 belongs to H. Also the same way, V1 belongs to K and V2 belongs to K. That means V1 plus V2 belongs to K. Therefore, W plus W1 plus W2 belongs to H plus K. Therefore, H plus K is closed under vector addition. Now let us take CU1 belongs to H and CV2 or CV1 belongs to K. That means if we add them, CU1 plus CV1 belongs to H plus K. Therefore, CW1 is equal to CU1 plus CV1. So CW1 belongs to H plus K. Therefore, you can say H plus K is closed under scalar multiplication. So let us take this as equation number 3, this as equation number 2, and over here so here you can say that is 0 belongs to H plus K, and this is equation number 1. Now finally you can conclude from 1, 2 and 3, H plus K is a subspace of V.